Welcome to video 2 on double integrals using polar coordinates. So we're doing another one of these problems, except our region is a little bit more complicated in this video. We have R is the region in the first quadrant enclosed by the circle x squared plus y squared is 16 and the lines x equals 0 and y equals x. So we have our double integral, R is our region, and we have 2x minus y dA. So remember what we're doing is we have to first draw our region. That's something that I didn't say in the previous video, but I did do. We have to draw our region. It's very important because it's easy for us to visualize as humans, for most of us to visualize, and that's what helps most of us. Remember, the quadrants go like this. This is our first, this is our second, this is our third, and this is our fourth quadrant. I like to think about it as a C shape. And so that's how we do the quadrants. And so remember, it's only the first quadrant, so we really need to magnify our first quadrant. It's enclosed by the circle x squared plus y squared is 16, which can be written as x squared plus y squared is 4 squared. 4 is our radius. And so if we were to plot this, we'd have 1, 2, 3, 4. 1, 2, 3, 4. It's not very equal, but you get the idea. We can plot this this circle-like shape in the first quadrant. We don't really need to plot any other things. And then we can do x equals 0, which is basically just when x is 0. So that's the y-axis, right? That's the y-axis. We don't really need to plot it, but it's just this. Remember, it's just this. Okay. Now, the reason why they give you that is because we also have the line y equals x, which is over through here, like that. That's okay. It's an okay drawing of it. And if it's bounded by the y-axis, then our region is not this region. It's not this region. It's this region. That's our region, right there. Since that's since we know that's our region, we can now set up our bounds, and that's the important part of this problem. Really, setting it up is the most important part. Okay, so how do we set this up? Well, let's draw our integrals here. So we have our integrals. And what we can do is outside is always going to be theta, because theta is what is going to be a constant to a constant. In this case, it's going to be this angle that we represent with this line. Now, keep in mind, y equals x is going through the center. And if we think about the center, if this is pi over 2, right, this line, and this is 0, the center is going to be half of that. So what's half of, well, pi over 2, right? Pi over 2 divided by 2, that's pi over 4. This is pi over 4. This is pi over 4. And then this is, of course, pi over 2. So we're going from our bounds are pi over 4 to pi over 2. So those are where we're going from. So pi over 4 to pi over 2. This is theta. Theta equals pi over 4 to pi over 2. And then our r values are going from, so this is the interesting thing. How we determine our r values, again, we're starting at the origin, and let's enter into our region. We immediately enter into our region, so that's starting at 0. And then we're going, as we go along, we're ending at this value of r, which is represented by r equals 4, because we established earlier that our 4 is our radius. And so r equals to 0 to r equals to 4 is the bounds for r. And then we have something for 2x minus y converted to polar regions, so polar coordinates. So 2x minus y can be expressed as polar in polar coordinates, because by thinking about x as r cosine theta and y is r sine theta. And so we can replace x with r cosine theta and replace y with r sine theta. So it's 2r cosine theta minus r sine theta, which is what we can actually include here. So we can add 2r cosine theta minus 2r sine theta. That's conversion. And of course, dA will be r dr d theta. Remember that r. That's it. That's our setup, really. This is honestly going to get you like a lot of credit, right? This is the hardest part, really. The integration you should know how to do, really, because it's not too hard. The hardest part, again, is the setup. Let's go ahead and solve this now. What we're going to do is we're going to split this up. And well, there's two ways to do it. Okay, let me do it in the different way in this video. In last video, I talked about how when we're multiplying things, we can or when we have like something with r and theta and we're multiplying them, we can split up the integrals themselves and multiply them. Let's do that in this one. It's not apparent how we can do it, but we can. And I think I accidentally added a 2 here. It's not supposed to be there. This is 2r cosine theta and r sine theta. Now, what we can do here, it's not immediately apparent, but it will be in a second, is we can rewrite this. So this is going to be from pi over 4 to pi over 2, from 0 to 4. And if we factor out an r, this is going to get us 2 cosine theta minus sine theta. That's basically the same thing, right? If we factor it back in. And then well, I forgot to factor this r in, actually, so let me actually do that. So first, if we factor this r in, we would actually just get r squared, because remember, we can take out an r squared, because this is going to be r squared, and then this is going to be r squared. So r squared can be factored out. So that's basically what's going to happen, and then dr d theta. Okay, so now that we have our r and our theta and they're multiplied together, we can actually express this, and I'm going to scroll down a little bit, we can express this as pi over 4 to pi over 2, and this is going to be our theta, which is 2 cosine theta minus sine theta d theta, multiplied by, we're going from 0 to 4, r squared dr. Simple as that. And this is much easier because these are stuff that you should know how to do if you're in this class, right? If you're taking this, right? So this is not hard, because what we can do is we can actually, both of these are really not hard. Integral of cosine is not negative sine, it's sine, so it's 2 sine theta. Integral of sine, however, is negative cosine theta, so it's plus, right? Cosine theta. Simple. Going from pi over 2 to pi over 4. All right, that's not too bad, hopefully. So let's see what we can do next. What we can do next is we can multiply that by r to the third power over 3, and then we can go from 4 to 0. All right, so let's see here. If we see, okay. All right, so if we go ahead and evaluate this, let me show you the steps. We would have 2 sine of pi over 2 plus cosine. Again, you can skip these steps. You can go directly to the answer for some of these, because it's not too hard to do in your head. But I like to do everything. Only if I'm on a time crunch I can rush, but it's fine. We can have cosine of pi over 4 here. Close, and then times. We have, I'll not include the 0. We'll have 4 cubed over 3. There you go. All right, so let's see. Sine of pi over 2 is, let me scroll all the way down here so we have some room. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. Sine of pi over 4 is root 2 over 2. Okay. So then, let's see. Cosine Cosine of pi over 4 is also root 2 over 2. We have that. And then that's pretty much what we have to do with that. And then 4 cubed is, let's see, what 4 cubed is going to be. 4 times 4 is 16 times 4 is 64. 64 over 3. So this is going to be 2 plus 0, and then minus root 2, and then plus root 2 over 2. I think that's supposed to be correct. And then times 64 over 3. And that is going to simplify down to 2 minus root 2 plus, 2 minus root 2, and then minus root 2 over 2. All of this times 64 over 3. So 100 and actually before we do that, let's combine these two here. So that's going to be 2 minus, so this is 2 root 2 over 2, which is gonna give you, so 2 root 2 over 2, this is minus 2 root 2 over 2, minus 2 root 2 over 2 minus root 2 over 2 is minus 3 root 2 over 2. So 2 minus 3 root 2 over 2. So it's 2 minus, and then we have 3 root 2 over 2. That's pretty much it. Times 64 over 3. The reason why I did that so we can just combine it easier. It's 128 divided by 3 minus 64 times 3 is 192. 192. Root 2 over 6. Okay. What's 192 divided by 6? That's going to be 32. 32. Root 3. Or root 2. And that's your answer right here. It's kind of a messy answer. It's not as neat as the one we had in the previous video. But it is an answer, nevertheless. And again, this answer right here represents, again, it's kind of interesting that we can find this using some algebra and some calculus. Really, what we're doing is we're finding not the area, but the volume of the essentially the shape that we get when we essentially have a shape that's above this region below the surface 2x minus z equals 2x minus y. That's basically what we just did.